Stanford University.
So the technical lead at Google Creative Lab, and again, that's 2 weeks from now. We do have a sign-in sheet for people who are taking the course for credit. Julie has it, and it's going to circulate right now. And then I'd love to welcome Leila Takayama from Willow Garage. Leila did her PhD here at Stanford in communication, working with Cliff Nass, and then you did your undergraduate at Berkeley.
Yeah.
So who are you for in the big game?
Berkeley.
Really?
I gotta say. Yeah.
You did not
I'm a bear. I know I didn't, but I gotta be honest. Thanks for the intro, Stephen. And thanks for having me here at the PCD lecture. I actually was here as a grad student taking this class, watching it from TV in my dorm, and coming here in person sometimes too. And I really enjoyed the lectures that I had here. And thought it would be really fun to come and get to do one myself. So thanks for hosting me. This is great. So what I'm hoping to do here today is convince those of you who are doing human-computer interaction that maybe you should switch over to robots. Robots actually aren't that much different from computers. The only big difference is that they actuate, right? We use sensors in computer science. There's a lot of processing in computer science. And we just have different actuators in robotics. And there's actually some really interesting interaction design problems where the field needs your help. There's many ways that people interact with robots, which is probably stuff you've seen before, people playing with their Roombas, cats sitting on top of them, and all that good stuff. But there's also how do people control robots? And I actually feel like if HCI jumped into that space, we could do a lot of good kind of damage. So I'm going to talk about a bit of that here. My hope is that I'll be able to answer at least some of these questions for you, and if I don't, hold me to them, and I'm happy to talk with you more about them either here or offline afterwards. So what is human-robot interaction? If you look it up on Wikipedia, it says the study of people interacting with robots, which is not very helpful because that's using the same words that are in its title. If you look at human-computer interaction, they do the same darn thing. So that's what I call human-robot interaction. I'm not going to put it into words for you, but it's something like people interacting with robots, through robots, getting robots to do things that are actually useful for people as opposed to just useful for themselves. It's great to have robots that run around and plug themselves in, but if the robot's not doing anything good for me, then I kind of don't care if it can plug itself in. They should be doing things with and for people. One of the nice things about human-robot interaction that I think is also great about HCI is that it's very interdisciplinary. So there's folks like me who are the fuzzies, right? We study people. But then there's also folks who are very hardcore technical, from mechanical engineering, EE, computer science. And you get to work with all of these really interesting folks, and especially design. This is actually a space where I think a lot more attention could and should and hopefully will be paid in terms of industrial design. So how do you design a robot so that people kind of get it? Right, so if a robot, for example, ours, seems to have really buff arms, but can actually hold 4 pounds, that's sort of a mismatch in how you're setting expectations for the robot just by its physical design. And furthermore, especially with the interaction design, you can make a robot that moves around like WALL-E, sort of meek and cute, and that sets your expectation for what that robot can do. Whereas you could also have, big Terminator robot, and that sets different expectations. The research I'm going to be talking about is not wed to any particular method, so we're going to be using a smattering of these depending on what the research questions sort of require. And I'm going to tell you a little bit about Willow Garage because you may not have heard of us before. But I run the human-robot interaction research there, and we focus a lot on how do you do studies that can both inform theory, so how we understand the way that people interact with robots, but also how do they inform design? How does it change the way that the robots are built, what they're used for, and how they're used? So at Willow Garage, we have many areas of focus, but the main ones are this. We're trying to build hardware so that people can build software so that robots can help people. The hardware platform that we focus on is called the PR2, and actually PR1 was made here at Stanford by Keenan Weirobeck and Eric Berger. They went on hold for their PhD program to build PR2 at Willow Garage, and it stands for Personal Robot 1 and Personal Robot 2. It's a mobile manipulation platform, which is a fancy way of saying it drives around and grabs things. On top of that, we have our software stack, ROS is the robot operating system. It's a BSD licensed open source operating software for running all kinds of robots, not just the PR2, but everything from Lego's Mindstorms and iRobot Creates, all the way up to big autonomous cars and boats and helicopters. And on top of that, right now, we're starting to look at building HRI applications. So using these platforms for rapid prototyping, using the software that you can actually share with the world and build upon the results of others, we're trying to get robots to do useful stuff for people. Just to give you a sense of what our hardware looks like, this is an example of the tests that we run on our software. So Keenan and his team have actually worked really hard to beat up the robot as much as they can. And the reason for that is so that you as software developers don't have to worry about having buggy code. So say you buy, a $200,000 hand, and if you just sort of look at it funny, often they'll just break. And what we really wanted was a more robust platform that you can test more quickly because you can be a little more rough with it. It's okay if you have bugs in your code because the hardware won't break. After we test the little subcomponents like that, we also tend to, torture the big robots. So this is the PR2 in a hot box that's over 100 degrees and very high humidity, just to see how much does it take to actually damage these things. And what you get after all of these iterative prototyping cycles with hardware is a system that's a lot more robust and can be used by grad students to do their research and get on with innovating and stop worrying about having to build their own little robot in their own little closet to do their research that no one else can replicate. If you look at a lot of robotics research, you'll see that it's sort of demonstration by video, and that's something that we're trying to stop. It doesn't count if you just make it work on your little robot that no one else has with your code that you don't share with anyone. It counts when people can replicate what you've done, improve upon it, and show that their stuff is better, and then give that back to the community. So that's sort of the basis of our company, is to get robotics to be a real science and to get to move forward faster. While we were building this guy, this is called the PR2, another robot appeared that I'll show you now. So our coworker Dallas, who's the guy in this thing that's sort of like Skype on a stick, got really tired of being a little polycom system, like the voice in the box on the table. So we work in California, but he lives in Indiana. And so he often would be engaged in discussions and arguments and heated debates with us, which is great, except that people would hang up on him whenever the debate got too heated and he was being annoying. And so he decided, well, okay, I'm going to get on Skype. Skype's going to be so much better because then they can see me. And so we put Skype on a laptop on a cart and pushed him around, which was kind of nice. He could come to talks now, which he couldn't do before. But then when he'd come to talks and he wants to look around the room, he'd have to say hey Kurt, can you move me to the right? Move me to the left. I want to face that guy. And that got frustrating. And so since we build robots, they took some spare parts from PR2 and built this. So now he can drive his own body around. So this is sort of what it normally looks like when we're interacting with Dallas. I actually know him better through the robot than I do in person. So he just sort of hangs out, comes in the hallways. He'll, pounce on you if you didn't answer his email and get you to respond. So he's become a more active member of our community in that way, which has been really interesting because this is where the people are at. There are many other systems that have existed before this. So I don't want to fool you into believing this is a new technology. This is a very old technology. It's been around at least since the 90s. So Eric Paulos and John Canny at UC Berkeley had a system like this in the late 90s that even had a little arm that could point and drive around. But back then, the Wi-Fi networks weren't as good as they are now. And so it was a lot more expensive and difficult to run that system. Now that the Wi-Fi networks can actually handle streaming video up and down pretty reliably throughout a building, these are actually in everyday use. So Dallas uses this system many times a day for 5 days a week while we're working, and sometimes even at night. He'll come to lunch with us whenever we're eating at the lunch tables. And because people are finally actually using them, we're learning a lot of interesting things about that from an HRI and an HCI perspective. So this is how we normally see Dallas using this system. We call this system TechSci just because Dallas is in Texas and that was a cute name. But it's probably not going to keep that name. And because we found it to be useful, we thought maybe other people might find it to be useful too, and it'd be more interesting to study them in other types of environments. So we built 27 of them and have been putting them out in the field so that people can try them out. People who are not roboticists, because roboticists probably act differently around robots than the rest of us. So those are our hardware systems. We built 27. There are, I think, more than 25 now. Yeah, about the same. The PR2s are very expensive. Yeah, they're quite a bit cheaper. I don't actually know the cost for them, but the PR2s cost on the order of about $400,000 a piece, the big guy with arms. These other ones, the Texi, are not for sale, but we use them as prototype units, and we're trying to see, maybe they'd be useful as a real product. And there are companies out there already who are selling these, so they do believe that it's a real product now. So those are places like AnyBots down in Mountain View. They've got some neat systems that are very similar. So now I'm going to turn to the research a bit. So the stuff that I do is the human-robot interaction stuff. And the fun thing about being at Willow Garage is that we get to do the science that works together with the technology. And the cool thing about that is that we can bring in findings from science that already exist and help them to redesign robots in ways that are more informed, right? So those are systematic technologies. Michael Poliani called this systematic technologies. But the other fun thing is that there's these things that we'd call empirical technologies. Like this thing appears. Like a text literally just appeared one morning at our standing meeting, and it inspired all kinds of questions and research and other directions that we wouldn't have thought of if we'd just been sitting in the armchair thinking about, oh, what would be neat to write for a Chi paper next year. So in general, what we try to do with the HR research is sort of influence products. So when I joined Willow Garage, we were really worried about this head for the PR2. The way that it was designed before I got involved was it had a stack of about 8 cameras piled up high on top of the thing. So it would look sort of like this 500-pound tarantula. And I cannot run HRI studies with something that looked like that, so we sort of smashed it down, made it look like it's got more like 2 eyes, and set expectations lower by making the head flatter. There's actually really good work by Jody Forlisi and Carl DeSalvo looking at, if the shape of the head is something like this, people tend to think that that robot's smarter than if the shape of that robot's head is more like this. And so we made it a little more squat, because we don't want people to think, oh, it's a genius. It's this really smart robot that costs a lot of money. We want them to think, this is just a platform. I'm going to use it to do my work. The other things that we look for are application areas. So what should these robots be doing? And behavior, how should they be doing them? So now I'm going to launch into a bunch of studies and then wrap up with some theory. So one of the questions that we've been really worried about is how do you set expectations for robots? When you give a robot to a person, what do you tell them about it? And it seems sort of tempting to say, like, this robot's awesome, you should buy it, it's going to be so useful, it's going to do all of your laundry and everything. But then you face the consequences of what happens after you say that, and it can't live up to those promises. And so how should you set those expectations such that people actually have a good user experience with the system? Goffman has this really useful framework for thinking about how people do face work, how they present themselves to other people in certain ways so that they sort of know how to interact with you. So the way that you interact with, say, your parents and your family at Thanksgiving might be a little bit different than how you interact with your colleagues when you go to a conference. And how should robots do that with, end users as opposed to people who are roboticists who are trying to hack them? There's a lot of theory in social psychology that would say you should probably set expectations really high because people will believe it. So if you go into a lecture and you tell half of the students, Professor Smith is a bore, they're not going to like that lecture very much. They're actually not going to learn as much either. If you tell them Professor Smith is really interesting, they're going to be more engaged, they're going to believe that he must be good, and they're actually going to get more out of that lecture. Same thing happens when you tell teachers, this student's really smart and gifted and this student's not. They actually end up calling on that smart and gifted student more, which gets them to learn more, and then they perform better than the poor kid who was, framed as not being all that great. And so maybe that's true of robots too. Let's find out. The other theory that's useful here is the confirmation bias. So if you take a really polarizing issue, say pro-life or pro-choice, and you have a big debate, what usually ends up happening at the end of that debate is that people are more polarized than they were to begin with. They don't change their minds and switch sides. They tend to dig in their heels and get even more confirmed in their beliefs that they had before they went into the debate. And so maybe that's true here too. But the counter-argument to that actually comes from business. So in management sciences, they tell you should always under-promise and over-deliver. So you tell them, we're going to finish this in 6 months, we're going to have 10,000 units. But you actually get, in 4 months, 20,000 units, and then your manager loves you and it's all great, you get a bonus. But there's not a lot of empirical data to back that up. And if you look at the way that the companies who make many personal robots today talk about their robots, they seem to not be listening at all to this system. So, if you try to say that Pleo feels hunger and fatigue, that's reading a little bit too much into what the system actually does. It behaves as if it feels hunger and fatigue, but it may not necessarily actually feel that. And same with Aibo, right? It's going to become your pal. It's going to be just like your best buddy from kindergarten. Like, that's not true. But it is a good way to sell a product. So what we did in this study was we had people have an open-ended interaction with these actual robots, and we just told them either this or this. And we left it on a sheet and paper in front of them just in case they forgot about it. And we told them, just come in here, try playing with the robot. Whenever you get sick of it, let us know and we'll stop. Right. So this was the experiment design, and this is what the people in that study were sort of like. They either interacted with a Sony Aibo or an Ugobi Pleo. We set their expectations, they have freeform play with the robot, we asked them some questions about it afterwards, and then we tell them what the study was about. They either interacted with Pleo or Aibo. If people had experience with either one of those, we swapped them out for the other one. So this is not too surprising, but before interacting with the robot, if you tell them the robot's pretty smart, they believe you. So they think that the robot can perceive people better and sense touch better if you tell them that the robot's smarter than if you tell them that the robot's not so smart. What's more interesting is that if you look at after they've already interacted with the robot, they get really disappointed if you set their expectations too high. They don't think that it's as smart as you told them it was. And what's even more interesting is that if you set their expectations low, they think that the robot's smart and smarter than if you would set their expectations high. And that holds true across both types of robots, which is kind of neat. And so that suggests that, here the business schools won. It probably is better to under-promise and over-deliver. But what was more interesting for us, actually, that we didn't intend to find was a lot of qualitative results about the ways that people were actually playing with these things. And when you watch the videos afterwards, a lot of them talk to these systems as if they were pets.
Stand, sit, stand.
Right, and that makes sense for Aibo. I'm not sure it totally makes sense for Pleo, although Pleo's interaction design was designed to be kind of like a golden retriever puppy. Yeah?
Coming later, but did you have anybody that sort of jumped out of the experiment and said, you're trying to set the expectation?
Nobody quite got that. They were like, oh, this is a really cool system, you should sell it. Many people didn't know they were real.
No extreme empiricists who said, I'll
not in this particular
give me a
sample.
screwdriver and then I'll
You're right, I can make it smarter. Yeah, we didn't get that in this particular study. In some of our other studies, they do guess what our hypotheses are and they'll call us on it, but not this particular one. Some other interesting things that happened was the creation of false beliefs.
Leaf? Oh, that's cool. It seems to understand leaf.
Leo does not understand leaf.
What about tree? Cookie?
Right, so this user sort of, it just sort of happened to do a noise and make a motion that kind of looked like maybe it understood leaf, and so she's sort of testing this hypothesis that maybe it understands cookie or some other words. And this participant was told the robot's pretty interactive and can interact with people. Another guy wanted to test whether or not it could sense a cliff and not fall off the edge of that table. So watch his hands. Oh.
Move. Nice.
He stopped the robot.
Move. Wow, nice. So it does do navigation stuff.
Right, so this guy was told that this robot is pretty good at interacting with people, and he wanted to see if it could do something that he thought it should be able to do, which is not fall off of a cliff. He helped it to not fall off of the cliff, and then was impressed that it didn't fall off the cliff. And so, people want to believe some things and will do things to help the robots to get there, and maybe that's something we could design for. But it's kind of interesting to see how these things play out in their actual interactions with them. One more participant was told, this robot's very smart, see what it does, and he let it fall on its table, which broke its arm and its ear, and that's not a robot you can actually replace anymore. This participant was told it's not that smart, and she actually held her hand below the edge of the table to catch it from when it would probably fall.
Yep, definitely can.
Right, definitely can fall off the table and not see what it's doing. And so we've been noticing these things that, setting expectations not only changes the way that you perceive the robots, but also the ways that you interact with them. It changes how much information you'll sort of breathe into them and help them to perform with. So in terms of implications for theory and design, I think actually face work and expectation setting might be a useful set of constructs to use for designing these robots. And in terms of design, it probably is better to under-promise. You don't want people to think your system's too smart and then they interact with it and get disappointed. So we've been seeing how robot behavior sort of influence people and how they make sense of them. And we decided to do another study that's actually under review but got good reviews, so I think it's going to get in, I hope, at HRI, looking at how can we help people make more sense of robots' behaviors before they do those behaviors. So at Willow Garage, we spent a while trying to get our robots to plug themselves in and to open doors themselves. And that's sort of nice as a feature for the robots so that it can get around a human-populated environment. So this is how that worked.
For the detection of the door, we use a tilting laser scanner to acquire a point cloud of the door. First, we use the geometry to detect the door plane. And then after that, we use the intensity of the laser scan to detect the door handle. Once we know the position of the handle, the nav stack calculates a path for the robot base to move it in front of the door. And then the arm can go grasp the handle, turn it, and start pushing on the door.
Alright, so that's pretty cool, but you may have noticed that it was kind of slow. So, when a robot comes up to the world, it doesn't have this entire semantic model of the world that we do. When we walk up to a door, we just know it's a door. But when a robot walks up to a door, it needs to see the plane, figure out that the plane is something door-shaped like, it's matching it against patterns that it has in its database, it's looking for a handle, and that handle is actually shiny, which makes it hard to see. And it takes a while. It's actually not a very easy thing to do, engineering-wise. But for those of us who have to actually sit next to this thing while it's learning how to open doors, it can be a little frustrating, especially for me because this robot was standing between me and the coffee machine in the kitchen. And so I would often run in front of it to go get my coffee and then get yelled at by the vision guys who are like, you screwed up our point cloud. And so I was trying to figure out how to deal with that problem. And we actually got in touch with a guy at Pixar, Doug Dooley, who's a character animator. Because animation has all these really nice ways of breathing life into things that are inanimate, right? And they do these cool things like, before the character runs, they'll sort of like wind up and then run. And that's so that the viewers know it's going to run. Oh, it ran. I saw it run. And they can get it instantly. Can we use that for robots was the question. So right now, this is what it looks like when a robot is opening a door. So it'll just sort of sit there for a really long time, and then eventually it'll reach out for the handle. Oh, it'll totally ignore the person who comes up next to it, and it'll do its thing. And that's fine if you're in an environment where there's no people around who are trying to run in front of you to get coffee. But what can we do to make this a little more readable? So these are Doug's animations, not mine. I kind of love them. So it acknowledges the person, sees them, and then goes to the door. So you saw it kind of, at least look like it's thinking for a bit. The other thing we did was robots know when they've succeeded or failed. They're given goals, like open a door, but then when they succeed, they just sort of, that's nice, and then they'll drive through it. We thought, well, maybe it'd be nice if it actually, reacted to its success. Brags a little. And even better, when they fail, they're really dumb. It's frustrating when they fail because you don't know if your software hung. You don't know if there's something wrong with the sensors, if it died. But if it shows you that it failed and maybe feels a little bad about it, right? That could be a little bit better. So what we did in this study was actually showed a series of these animations across a bunch of task domains, asked people, what would you do if you saw a robot doing this? And what did you think about it? These were the domains that we looked at. One was, delivering a drink. Another was ushering a person, opening a door, which you saw, and then asking a person to plug itself in. Not too surprisingly, if the robot shows forethought, so that, head scratching or something like it, people find the robot to be more approachable. They also think that it's got a little more appeal than the other robot that doesn't, even though it's the exact same robot, just different behaviors. Yeah, sure.
Look like that.
Well, that didn't feel like making them look any more interesting. They do. He spent a ton of time getting the kinematic model right for the robot, and by the time we threw people in, he was like, let's just do it. It would be nice if they looked more like people. We should.
We should approach the robot
Yes, yes. That would be easier to perceive. Yeah. Yeah, it was the people do not look nearly as high fidelity as PR2 does. No, it's fine. What was actually more interesting was how smart they thought it was. So if you ask them, you know, how competent or intelligent you think the system is, if it succeeds, do you think it's smarter? If it fails, do you think it's dumber? But what's cooler is that if you at least react to that success or react to that failure, you also get brownie points. People think you're a little bit smarter if you at least do something to respond to your success or failure. Yeah.
These were all animations.
Yes, they were all animations.
Were the participants looking at it from the outside and seeing a person, or were they seeing it from the perspective of
They saw it from the same perspective that you saw it from, right?
They were
Your third-person point of view. I actually think it'd be really different if it was first-person, and that's what we're planning on running next. So we can actually play most of these animations on the physical PR2 and try it out. And I think it's going to be different. It's going to be more visceral, probably, than it was from this sort of like third-person point of view in a web browser in this abstract animation.
So they're on the fourth wall.
Yeah, yeah, yeah.
How about R2D2 type sounds?
Yes, yes, yes. I'm getting right there. You're way ahead of me. So, you know, animation is actually largely driven by sound. You know, Ben Burt at Pixar is just this god in sound design. And what we did was we worked with E.J. Holowicki, who's a sound designer at Pixar, to look at sound libraries for these robots. We don't have our robots speak right now because they can't listen. But what we can do is make other types of sounds. So here's a few from the libraries. Right, that's the most R2D2-like set we've got. And we actually, because I've learned that nobody agrees on what the best sound design is for a robot, we've done a bunch of them and posted them online. They're Creative Commons licensed, so feel free to use them for whatever you'd like to use them for. We thought it'd be nice to use for PR2, but of course other people have other robots that they like to have speak. A lot of people use Festival to get their robots to talk, and I'm getting a little tired of hearing the same voice coming out of every single robot. It'd be nice if they're a little more unique. And you can be expressive in ways that use just pitch and tone and timbre, right, instead of speech. It doesn't have to be words to be communicative. All right, so far I've talked a lot about people interacting with robots. Now I'm going to switch gears and talk more about people interacting through robots. So more of that like sort of Skype on a stick text-size system. One of the questions that we have is like, okay, so we've got this new system, so what? What are people actually going to do with it? How are they going to form social norms around it? How are they going to make sense of this thing? So what we did was we threw it out into a bunch of companies in the Bay Area and watched them use it. This is what the user interface looks like right now. Yes, it probably needs help, and we'd love it if anyone in this room would be up for helping us with doing this better. This is Skype, right? And you're seeing the head view camera up there. So that's looking from the top of the screen. And this is your navigation view, which is a little camera below your screen that's looking at your feet. And the reason you need that is because it's easier to avoid hitting things if you can look directly at the ground. This is the navigation interface. You drag the little red ball around to drag your body around. And that's about it. You've got a pan tilt camera also. It's just the orbit cam. So you can look from side to side and up and down, but you cannot zoom right now. This is how the TechSite usually gets used at work. We just snap these pictures around the office. So Dallas tends to attend meetings in the TechSite, and he'll stand at the end of the table because his angle of view is not quite large enough to sit in the middle of the table yet. So he'll sort of be at the head. But the way that it gets used more often is that Dallas will just sort of walk into your office and start talking to you. It's a more informal type of communication. But of course, you know, we're in a robotics company, and so people are going to act differently around the robot. Plus, we built this one, so we're very ego invested in it. And so we'd like to see how other people use it. So looking at a couple of other companies, I think 2 other companies in this data set, we looked at what people did with them and where. So what's interesting here is that the things that people were doing were actually very work-related. They were getting stuff done through these systems. They weren't just chit-chatting about how cool the robot was. And where it's happening is even more interesting. So if you think about, you know, big teleconferencing systems that are a big screen on the wall, those are in meeting rooms. You could probably put them in the hallway, and if you really wanted to spend a ton of money, you could put them all over the building. But with this system, you can just sort of roll around the hallways. You can go into someone's cube and talk to them. And they get used mostly in, you know, larger communal spaces or in people's personal workspaces, not hardly at all in the conference room. So I think they're actually in sort of different domains. They're both about remote communication, but they can be used in very different ways.
Yeah? On that last slide, is that because there's an alternate technology for conference rooms that works fine, or is it because at Willow people spend very little time in conference rooms?
We spend a lot of time in conference rooms, and we're very frustrated with our current conferencing system. But this is also the other two companies where they have like one has a large Polycom system and one's got a big Cisco system. Those rooms tend to be booked a lot too. Because they're very expensive, most companies only have a few. And so this is a pretty good alternative to that. I think that probably has something to do with, there's existing things that are okay already. I have seen meetings where there are tech side present and the big system present. And the people in the robot tend to be, in the very beginning, they get a lot more attention because it's new. But towards the end, it's a lot more normal because they just sort of take a space at the table, as opposed to being this like thing stuck in the wall.
You get the remotes.
Usually whoever's the real remote worker, so, we could log into the tech side and drive them around like RC cars, but we try not to because Dallas actually needs it to get work done because he lives in Indiana. That's how we give priority.
So, you talk about the experience of the people who are working with the robot. How is it at the other end?
Yeah, that's what I'm getting to real quick. So this is both from the pilot. We call them pilots because they drive the system around, and the local. So those of us who are local to the robot. That's just, for now, that's our vocabulary. But across both of those, they think it's better. I'm not sure how much I buy this because of the questionnaire, but it's something that I'd like to actually, observe more in the field. Yeah. He's an electrical engineer, which is actually tricky because it's very physical work that he does. So when he needs to build things, he'll often build a prototype and then ship it to us. But what's nice about this right here is that he can hold it up to the camera and show it to us before he locks in a design and can send it back to us. He's also, because we're a startup, a lot of people play many roles. He's a bit of a systems engineer also. And so he'll often, work across a bunch of teams. So he does a lot of collaborative work too, but his core job is a double E. Any other questions so far? Yeah.
So I understand that the telepresence robot is cheaper than the other robots.
But that's not saying much. Yeah.
But what if, like, a company has 10 teleworkers?
Right.
And they can't afford 10, but they can afford one.
Right.
Should they then share it, in your opinion, or should, because it's one person, one robot, should really be embodied for that particular person and the other should not benefit from that? What would you say to a company that has that problem?
We have been sharing it, and it's actually raised a lot of new design issues that I think we can deal with, so I think it is okay to share. So Dallas uses these for about a third of the day, so he doesn't actually use it the full day, but a large part of it, and so you could timeshare on each one of them, kind of like you timeshare in a meeting room. What's been really interesting is, in the very beginning, Dallas was the only person in these systems, and so whenever you saw it rolling down the hallway, you could just say, "Hey Dallas, how's it going?" And as soon as the second person logged into that system, you can no longer tell like who's in the body now. And that I think is actually something that could be a real design challenge that we could meet, but we haven't done it yet. And so what people end up doing is not saying anything to the robot, and they feel a little more isolated now than they did before. So I think they're going to share, but if they don't, then you can do all kinds of fun things like personalize them so they look just like the person who's there. If you all watch The Big Bang Theory, there was a recent episode where they used one of our systems and they put Sheldon's t-shirt on the robot because he was the only one using it. And you get to do stuff like that when it's your own robot that you probably don't want to do if it's a shared body. Or you could imagine having, remote controlled skins or something. Where you could tell who was in the system or inhabiting the system at a given time. But we haven't done that yet. I do think people are going to share them, and I think it's going to be an issue. Just because at the current price points, you're probably going to have to do that. So one of the sites that we have been working with, 50% of their workforce is remote, and that's a lot of people. And they only have 2 systems that they're using. And so far, it's been kind of okay. Yeah. So looking a little bit deeper at the field observations that we've been doing with these robots, Bonnie Nardi has a really useful conceptualization for what people do when they're remotely communicating interpersonally, and those are these 3 constructs. So the first one of showing commitment, just showing up for work is half of being there, right? So when this pilot shows up to the all-hands meeting in a robot and takes a spot next to the couch to watch the lecture, he's actually demonstrating to all the locals there that he's going to take the time to be there, right? And it's important to him. He's not just calling in and like watching the video from the back like everybody else is. He's sort of, in a way, expressing his commitment to the team and being more of like the team. The other thing that they like to do, and that actually works, is capturing and maintaining attention. So when I don't answer emails from Dallas sometimes quickly enough, he can just roll into my office and sit in front of my desk until I show up in the morning and ask me, did you check your email today? And I have to answer in a way that I wouldn't have to answer if he just left a bunch of voicemails or text messages on my cell phone. They call that pouncing. And the last thing they do is build social connections. So I showed a lot of pictures of robots being used for work, and yes, they do get used a lot for work, but they also get used for like joining in the pool game. They don't have arms, so they can't play pool, but they can sort of like, you know, rib the guy who just missed his shot. And at one of our field sites, they actually have learned that if you hang out close to the coffee machine where people are held hostage for at least a few minutes while their coffee is percolating, you can get some good conversations in and get to know people that way. Yeah?
How about territorial aspects where, you know, there's the question of, well, which lavatory should the particular user go in? And then the question, of course, why is this thing in the lavatory?
Right. So our lavatories have spring-loaded doors, which means robots cannot get into them, thank goodness, because you could, you know, I could roll into the women's restroom and then walk away from my computer and let someone else log in who's not female, and that would be an issue, so we don't let them in the bathrooms at all.
Likely ones of just sort of invading personal space, you know, cubicles.
There definitely are.
Something that might appear to be snooping, but really isn't snooping.
Yeah. This happens with our autonomous robot too, the Pier 2. People get annoyed that the robot keeps charging down the hallway and making all this noise, and so they'll just put a big cone in the middle of the hallway so it can't get through. It's kind of like putting up your Roomba's extra walls so it doesn't fall down the stairs. You set up this like anti-robot zone, and it happens a lot. People know that the tech side cannot open doors, and so if they really don't want a tech side person coming in, they'll shut the door. And they know that the person can't do anything about it. What the pilots normally do if they really want in is they'll bang themselves against the door a bunch of times, which is the equivalent of knocking. And that'll work if they're insistent enough. It's okay, because that's what the bumper's for. It's okay to bang stuff.
They're banging the door, not the wall, I guess.
Yeah. They can bang on the window. Right, so we've been looking at, you know, what people think is polite and rude with these robots, and the most interesting thing I've been noticing so far is that depending on how they orient towards it, like, is that a robot? Is that a person? Is that some other weird thing? Is it a portal? They think that different things are polite and rude. So if you ask people who think it's a robot, how polite is it to play a prank on the system? They'll say it's really rude. You shouldn't play pranks on robots. But if they think about the system as like, oh, that's just Dallas, that's just the guy, that's just the girl who's in the system, then they think it's fine to play pranks on them because they're just sort of, you know, playing around. And that playing pranks happens quite a bit, which is why we asked about this particular question. And so when you hear people talk about the system like it's a machine, they usually say stuff like this. And it's often the pilots who think about the system as being more like them, like it's a person. They don't like it when people poke their volume buttons because that's kind of rude when someone like jabs you in the neck. I'm not sure if that's what the equivalent is, but there is a sense of personal space around them. They don't really like it very much when they get grabbed by the neck and dragged places, even though sometimes that's a faster way to get from point A to point B. One of the things that I didn't call out earlier that I wanted to call out now is that there are some tricky things going on here. So in this one particular scene, this pilot actually is probably checking his email during the talk. And you can't tell because his Skype camera is facing his face, but he's actually got his, you know, whatever up and can be doing other work while it looks like he's actually paying attention. And of course, you know, these other users are doing that too. But he's also got a wide-angle camera under the screen, and so if he wanted to read her email or whatever it is she's doing on her screen, he probably could. I'm not sure if she's aware of that. This person behind him can't actually see the presenter because his head's too big and it's in the way, so she's sort of like leaning over to the side so that she can see the presenter. And anytime you've got a robot in the environment, you've got cameras. Cameras can record. And so one of the rules, design rules that we have with these robots is no recording, audio or video. And if you see me, I see you. This is not a surveillance system. This is about people communicating. So we actually don't allow you to drive the robot unless you can see your face in your video feed. But of course, if someone wanted to, you know, they could do a screen capture on Skype. And that may become an issue, especially when you're running around office buildings. some other things we've been seeing is that people are drawing from not just interpersonal communication, but also other mediated forms of communication. So when you're done with a phone call, you just hang up the phone. And so when people are done with a roboting call, they just turn off the robot. But for the locals, that stinks, because that means you've just left a robot, you know, draining its battery in the middle of a meeting room. And we have to go put your body away. And so some of the engineers at our company will often, like, you know, comb the building and make sure that all the robots are back in their charging station at the end of the day, which is, you know, kind of an imposition for those of us who are not remote. And other times people talk about it, you know, it's kind of like when you're having to open a door for a robot, it's a little bit like opening a door for someone in a wheelchair. They liken it to other forms of mediated interaction. And of course, there's places where this breaks down, right? So it may be okay to hit the volume buttons on that little Polycom system in the middle of your conference table because, you know, you can't hear them well or they're being too loud. But if you do that on a system that's moving around and representing the person and the person's body, that's a little bit weirder. Great. Any questions on that so far? All right, I'm going to move on. So, so far we've talked about these systems being used in office spaces with mostly techie people. What we decided to do this summer with Janae Pier was look at, you know, what about other user groups? So one of the things that we've been noticing about Skype is that it's often used by, you know, grandparents and grandkids to talk with each other. It's not only the techie audience that makes use of video conferencing communication. So maybe people would, you know, like to see their grandkids in a robot. Maybe they'd like them to come in and visit them when they have time and if they live too far away. But of course, we don't really want to presume those types of things before actually trying it out and finding out. And so what we did was we brought 12 older adults into the lab to try out the study. We tried to get the robots into their living environments, but there were so many insurance issues that we couldn't get it approved. We're still trying. And so we did the best we could, which was to bring them in, let them have a conversation with someone through the robots. Someone would visit them in the TechSci. And then they would also get to drive it themselves and go visit someone else. So they sort of had both experiences. After doing that, we did some interviews with them and sort of talked to them about, like, what would you use it for? What are you concerned about? What do you think might be the benefits? And this is all speculative. It's not for real. We want to do it for real, but until we can do that, this is the best we've got. What was interesting here was that we thought they just want to see their grandkids, but that's not a very big group. They'd actually rather hang out with their friends. And many times they talked about their friends who were stuck somewhere, like in the hospital, recovering from surgery, or places where they thought their friends might be lonely. And so that might be a more compelling use case than just doing the grandparents, grandkids thing. The other thing that was really surprising to us was that we'd sort of imagined that people would want to be visited by their family members or visited by other people, so they'd be the local, right? And the robot would be in their home, and then people would come and check them out. But what they really wanted was to drive it and get out. So many of them talked about going out for walks in the park. If we could get Wi-Fi to work out there, that'd be great, and we could maybe do that. Maybe with 4G we could do that better. They wanted to go to live performances and go to games, like baseball games, and actually sit in the seats, not just be like something really far away with a nice camera. And go to theater performances and museums. So that might be, you know, where the action's at actually in this domain.
Hey, Leila.
Yeah.
One of the findings that people have for older adults is that the more active you are, the happier you are and longer you live. And obviously there's like a I exercise my body more explanation.
Right.
Could you use robots as asking that question in terms of, is part of the benefit just all of the social contact,
right,
even if you're sitting in a chair the entire time?
That would be a neat way of teasing that apart, I think, right? Because they're actually sitting in the chair. We've been thinking about making it so that pilots have to stand up too lately, because often when Dallas visits, he's actually sitting in his chair at home, like leaning back and just sort of relaxing, and we're standing, and we get tired faster than he does. So that issue of physical exertion, I think, is a biggie here. And like one thing we really don't want to do with systems like this is replace the exercise that they probably should be getting, which is going to be tricky, right? Because when you got a robot to drive around, it's tempting to just sit around and have the joystick in your hand. That's stupid.
You wonder whether you make it so that you have to pedal.
Yeah, it's like the hamster charged robot.
So the social interaction provides the motivation for actually doing more exercise.
That's an interesting idea. So you get so many robot minutes for however long you exercise. That would be neat. Getting people to do physical therapy types of exercise or even just normal exercise is really hard. And I think
it's sort of like the idea that one way you get people to exercise is to build it into the environment as a
Right. That would be a really cool space. Yeah, there's been a little bit of research that I haven't done, but Corey Kidd's done that we talked about earlier, that robots can actually help get people to exercise more than things that are on a screen, or just, normal methods of like writing down what you ate and how much you exercise on paper. I think this might be a good space for combining that work.
I almost say the same thing about, Tico Bayagas was here a few weeks ago talking about telecommunications with family members.
Yeah.
And you could almost say the same thing. It's an engaging activity. It's social. Right. You're communicating with friends and family. Right. Oh, let's connect a bicycle up to it. And
anytime you have a motivator,
you
have an opportunity.
Yeah. If people are very motivated to socialize, and actually when people get socially isolated, you tend to get more depression, and then you get, shorter lifespans. So getting them out more is a good thing. Looking at some of the concerns that they had, I was sort of surprised by the order of these. I thought that the biggest problem would be privacy, but actually what they talked about a lot more, like in terms of the amount of time, was how would you refuse a call from someone who you didn't really want to talk to, and how do you end a call? So because they actually tried these systems out, they realized, when you finish a conversation with someone in one of these systems, they don't often leave. At the end, they'll just sort of turn to their email and start checking their email. Which is weird because their physical body's still there, sitting in your office. And so we've taken on the social norm of telling them, okay, you can go now, go back somewhere else out of my office. But that's kind of rude to say to your family member, right? Or your grandkid, like, get out of my face. And so we have a lot of social norms about how to gracefully hang up a call, or how to, just ignore the call and call back later and make some excuse for why you didn't pick up. But we don't have that yet for these systems, and they're really worried about that.
You take the point of view of kind of categorizing or providing some information about the potential remotes.
Right.
So there might be corresponding questions about the locals in each one of these environments. Say, starting off with stuff like museums.
Right.
How do they feel?
Right.
What are their concerns?
Right. What I'm hoping with museums is that one positive is that people can't put fingerprints all over your paintings anymore. But a negative is that, you got to be careful with security. Like, when can people actually log in? How would they give your museum a donation? Because they don't actually have to come to the front door anymore, and they don't have hands to put that dollar bill in the case. I think it's actually going to fundamentally change the way that people visit places. When people come to visit us, often when folks want to visit us at Willow Garage and they're really far away and it's going to be a while until they're in the Bay Area again, we tell them, like, why don't you come in on a TechSci? But the problem with that is that they don't sign in at the door because they can't. And this has happened at a bunch of companies, and it's actually, it's a norm that's going to have to change, I think, if these systems are around longer.
In posing these sort of thoughts about experiments, the assumption is that these are personal. I drive my device out from my front door rather than a zip car kind of situation.
Right. So, if they are personal. Yeah, the shared systems, I think, are going to be pretty fundamentally different from the ones that are just me.
Virtual world, so that you virtually go into the front door, and then there's a certain point at which you
enter the real world.
You enter the mixed world.
Yeah, I actually think it'd be
similarly for going out.
Yes. Not everyone's good at driving these, and so we've been talking about having them certified with like a robot driving test in simulation first before we let them in the real system. Because something that's interesting is that a lot of kids mostly will sort of confound whether or not the real world is on the other end or that's a game on the other end. And so we actually had an event here at Stanford where a lot of kids came and they were driving the TechSci at Willow Garage, and they would go chasing after my coworkers trying to knock them down. And I had to tell them, like, that's a real person. Like, please don't knock down Brian because he's a nice guy. Or they would, bang into the wall as hard as they can because it's fun. And they sort of lost that sense that there's actually a real thing and there's real physical consequences on the other end. And so I think it's going to be interesting to bridge those sort of like virtual and physical worlds because there's different implications in either space.
Is that just a lack of feedback? Like if it hurt when you ran into the wall,
maybe.
would that
would
change
like shock them? Yeah. Help a little bit. Yeah, there's not nearly enough feedback in these systems. I actually think like most these could be very, very, very significantly improved by better interface design. Right now it's just a little web interface, right? You can imagine much more immersive interfaces. We're looking right now at, like binaural hearing. So if you put a football head with ears on it, it could actually feel like your ears are there and you can hear in space. So like something that's happened with Dallas is that he gets these drive-by greetings where people will sort of run down the hall and be like, hey Dallas, how's it going? And then walk away. And he's sort of left like, hi, who was that? And it's awkward for him, and it feels like he just dissed the other person by not responding fast enough to them. And so getting that sort of spatial sense, I think, would help, right? More feedback is better. More context awareness would be great. All right. So here's a big question. Why should you care? I think the reason that I care about this work is that when people's interactions with the world become mediated in these ways with robots and computer systems and whatnot, it's actually changing the ways that we perceive and act in the world. It changes the way that we see ourselves. It changes the way that we interact with each other. And that's really interesting. And that's particularly true when you've got very, very visceral kinds of experiences that are physical, right? So when you're driving a robot, that's a little different from just sending it a command that says, like, go to meeting room A. And that's interesting. I've been finding a lot of inspiration from just being around these robots, sort of asking new kinds of questions that I hadn't thought to ask before. And I think they're a really fruitful space for doing more research in human interaction with systems. And finally, I actually think that the HCI community has a ton that it could teach to the HRI community. I think that if you look at the HRI research right now, and they're starting to look at things like graphical user interfaces for controlling lots of robots. We've got a lot of literature on that already in HCI, right? And there's a lot that can be drawn both in terms of theory, in terms of design, in terms of design methods, even thinking just more about interaction design overall. Get more interaction design to robotics. I think that's going to be an important thing that we need to do before these systems get out into the everyday world in a more pervasive way. Something that I often get told at work and many other places, especially robotics conferences, is the robot's just a robot. Don't worry about it. It's just a tool. People are going to adapt. But I don't believe that. I actually think when people are actually interacting with the robot, they do these things that don't totally make sense rationally. So, when Dallas comes to a meeting, I just talk to him. I'm interacting with him because he's an agent. He's a real person to me, and I don't care that there's a robot there. That robot kind of disappeared. Same thing like when a robot comes and delivers you a beer. Like, people get really happy and they laugh and they thank the robot. And it's not because they're dumb. It's because they're in the moment of this interaction and it feels like an agent. And so they interact with it as if it is one. On the flip side of that, when people are teleoperating a robot, ideally, they feel like that guy is this guy, right? I am my robot. I'm just there, and I'm just interacting with the world. Dallas is just in our office. It's not like he's having to interact with a computer, with a network that's kind of buggy, and maybe he has power or not. And, it shouldn't be about him interacting with the system. It should be about him just doing stuff. And the robot happens to be there in the middle. In the same way, you could imagine robots that instead of having to tell them, robot, get me a Heineken, it just sort of knows you need a Heineken. Or robot, get me a coffee. Maybe I'm kind of tired and it should just bring the coffee. Are there ways that they can anticipate our needs and be a little more invisible in use, like Tim's work? And trying to anticipate needs, anticipate interruptibility, understand more about the human environment and the context and things that people are trying to get done in order to help them. So if we back up a bit into theory, I talked a lot about implications for design already, so I'm going to go into a bit of theory at the very end. There's a ton of work looking at how do you make things invisible in use? How do you get it to feel like the blind man's cane? So when the blind man uses a cane, this is one of John Seeley Brown's awesome slides. He talks about, you should just feel the world through the cane. It shouldn't be like, I'm feeling a cane, it's sort of hard, it's made of wood, it's kind of cold, and I'm using it to poke around in this space. It should just be like, I'm seeing the world. And there's a lot of work in this space. James Gibson, who's probably more famous for talking about affordances, also had some really neat ideas about how you become absorbed in part of your car. So if you have a really fast sports car, you've got this really long tongue that it sends in front of you because you can get places really fast. That's sort of your space of possible actions. If you've got a really old jalopy, then maybe that tongue's a little shorter because you can't get places real quickly. And if you have a very responsive car, right, that car can actually maneuver through spaces much more easily than if you've got a Mustang that just goes straight forward and hardly turns. And we sort of change our ways of interacting with the world and seeing like what I can do. So Merleau-Ponty talked about in terms of like what my sense of I can, and how does that change when you're interacting with the world through and with a robot. Scott McCloud, I heard, gave an awesome talk yesterday that I probably can't compare to, but he has some really neat ideas about this too, just with really mundane objects. So when you're using a fork and knife, you may not remember having to learn how to use that fork and knife, but you've become so good at it now that you just do it. You're just eating. It's not like I'm going to grab the fork and hold it up to my mouth now. So one way that I found of dealing with this thing of, we know it's just a robot and yet we can't help but interact with it this way. We can't help but feel like it's part of ourselves is this. In the moment of interaction, you've got this perspective, like you're just there, you're just doing something. It doesn't have to be rational. And yet we want to believe that we're reflective, very rational beings, right? We can step back from the situation and know that's just a robot, and that's fine. But we need to separate out those two dimensions.
What do you mean by, I mean, your use of rational seems... I think I don't quite understand it.
I think it means, so, if you can step back from the situation and see yourself from that third person point of view, I know that that's just a machine, I know it's just running code, and that's a rational belief, because I know it's just some hardware with some software running on it, with some sensors. But when I'm in the moment of it, and it's delivering me a beer, or it's me talking to Dallas, it doesn't, I forget that.
It's like if I have a cane, and I can perceive what's at the other end of the cane.
Right, right.
I don't think I would call that irrational.
I don't think that's irrational. I think maybe irrational is the wrong word. Reflective. Right.
Perceptual.
Unconscious might be better. Right. Visceral as opposed to something else.
Visceral versus reflective?
I think that would be better. Yeah. I tend to think of it in terms of, I tend to call it in the moment versus reflective. I'd be happy to throw it rational. Right, so if you split out those two spaces, you can actually get an interesting design space here. So you, as an audience member, you're a human being. I believe that you're very agentic. And in the moment when I interact with you, you also feel that way. If I've got a new hammer or a robot or whatever just sort of sitting around, it's just a tool. I believe it's just a tool, and in the moment it's just a tool. My foot, on the other hand, is a part of me. I believe it's a part of me rationally, and it feels like it's a part of me until that foot falls asleep, and then it kind of feels like this heavy thing just hanging off my leg, and I can't really control it because I can't feel it anymore. If you've ever walked into Walmart and seen a surprising surveillance image of yourself, that's an example of like you can figure out that it's you, but in the moment that you first see it, it sort of looks like this person walking around that might be somebody else. This is where I would put Cliff Nass's work in terms of computers as social actors. Like, we know that computers are just computers. We know that robots are just robots. But in the moment of interacting with them, it's really hard to interact with them in a way that doesn't make them seem like they're agents. Ideally, a really great service worker will provide such great service to you that you forget that they're there. And yet they're there as a human being, and you know that they're a human being, and you're going to tip them because they're providing you this service without being very visible. Herb Clark has this great example of joint activity where he talks about the ballroom dancing partners acting as if they're one unit, even though they believe and they know that they're individuals. You know, if you think about people riding horses, for example, can you come to a moment where you fuse as an agent and can interact as one? And finally, there's the carpenter's trusty hammer, the blind man's cane, right? So it comes to feel like it's a part of yourself. So here's where the robots are, I think. And this is sort of this fun design space of like, how can you make it when you're interacting through a robot, it feels like it's just part of you. Some people just, you know, prefer to control their robots and joystick them and drive them around. It's just a tool or it's just a toy. And then how do we deal with situations where the robots feel like they're agentic in the moment, even though we know they're not? So the first study I showed you was thinking actually about sort of how do you reflectively perceive the agency of the system? How smart do you think it is, and how does that influence the way that you interact with it? How can you read the behaviors of more agentic robots, or robots that are, you know, scratching their heads and trying to open doors? In terms of the tech side, people actually switch often between whether or not they feel like they're really there versus they're fighting with Skype to get it to work so that they can connect to the robot. And for the people who are local to the robots, so to the tech side in particular, they're actually interacting with the person, but they're kind of interacting with the robot, but it's kind of, maybe it's kind of something else. Right. So we've actually done a little bit of work using this space to think about, so what can we use from this space to figure out how to make things move in this direction or move in that direction, right? So how does a person become more like your ballroom dancing partner? And can we use those lessons to figure out how a robot could become more like something that you interact with, that you're interacting with the world through? Or in the other direction, right? So how do you become more agentic in a way that people will interact with you in that way? That you have agency even though you really don't reflectively. Yeah, Wendy.
So, as it turns out, on Wednesday, Michelle and I gave a talk, a local talk, talking about HCI in general and first person, second person, and third person interactions. And I would argue that those aren't necessarily on a continuum,
right.
but rather different relationships among the actors in that interaction.
So there would be nominal categories then?
Yes,
Yeah.
in fact. And that, in fact, there's a great deal of research that's been done in all three. And so the notion of empowering the user, the tool thing is, I am this,
right.
I'm using the technology to augment myself, versus I'm conversing with the technology, I have a dialogue with them, versus it's a medium through which I interact with other people.
That's cool. I think that would be a great way to map this space.
Yeah.
Actually, and that'd be really useful for robots and computers. Huh, that's neat. I'd like to hear more about that afterwards. Right, I'm gonna go here. So I mentioned, maybe we can draw some lessons from other domains. And so one of the studies that we actually did here at Stanford was just interview folks about, hey, have you heard of this blind man's cane thing? Can you give me any other examples of that in your everyday lives? And so we asked people about, what tools do you have that have become invisible in use? What happens when they, do they ever become visible again to you, and how does that happen? And we've been publishing on this research. The most interesting thing to me there has been that I thought that things that were very easy to learn how to use would be the things that become invisible in use quickly and that people would mention the most. But actually, driving a car, which was the most frequently mentioned answer, that's not that easy to do. It takes years. And if you've ever driven a rental car, it doesn't feel quite invisible in use until you get used to that thing, and it takes time. But because we have the incentive to take that time to learn to use that thing, it can become invisible in use. Another example is figure skates. Those things are not comfortable. They are not normal. We don't usually slide around with almost zero friction, and yet they can become invisible in use, with enough experience. Maybe it's worth giving it the time to become that way. The other space we've been looking at is more agentic objects. So, I've been interviewing a bunch of equestrians about how they interact with their horses. And what I'd rather actually do is go out and watch people do this now, because after talking with them, I'm realizing it's very hard to verbalize how you interact with the animals, like your companion animals. Donna Haraway's been doing some really interesting work looking at dogs as a companion species and how do we interact with them. I think there are some very deep lessons that we could learn from human-animal interaction that can be used in human-robot interaction. Animals are non-human agents. If you look at people who've owned pets before, they're actually a lot more comfortable around robots than people who haven't owned pets before. So there's a lot of open questions here. I'm not claiming to answer all of them at all. I'm just trying to poke around this space, and I'd love it if more people would join in this space too. There's just a little more actuation than in computers. So HCI is not really that far away from HRI. So a lot of people like to talk about this space of oh, you're directly teleoperating a robot, and roboticists will say that's bad, that's evil. You shouldn't do that. You should make fully autonomous robots that can do everything by themselves, and that's great. That's fine, but that sounds an awful lot to me like old school AI, where they said we're going to replace people with computers. Now we're going to replace people with robots. But actually, if you ask me, that's interesting. You can do a lot of things about what kinds of useful models are there to be used. But Bill's model, I think, is a lot better for this space, which is, what's in the middle? What's the stuff that you can do? So this is a human carrying a load all by himself, right? So that's kind of like the guy directly teleoperating the system. And at this far end, we've just replaced the person with the computer. To carry that exact same load. But really, all the interesting stuff is in between. How are people going to work together with robots to get stuff done? How can we get computers to not get in the way of the interaction, but actually support the person? Share the burden, maybe trade some of the burden, be the one that you can fall back upon when the system fails or when the human fails. How is it that we can work together with these systems to do interesting things and do more than we can do by ourselves? So that space is not mapped out totally well either. There's a lot of interesting work in shared autonomy, assisted teleoperation, supervisory control. We've looked at stuff like how can you get pilots of TechSci to not bang into walls, and we use the autonomous sensing and navigation to just replan the path so that they don't hit the wall. But then they also feel like they've lost control over the system when it does something different from what they told it to do. How are we going to deal with those kinds of interactions between computer autonomy and human autonomy? They're going to have to somehow match up together, and we don't fully know how yet. There's also some, more grounded questions, so for Dallas, what's it like? What's it like to go to an office in a robot for, a year and a half? That's a long time to spend. So sometimes he'll come to our office, maybe twice a year, and he'll sometimes complain that he can't really goof off as much during meetings as he can when he's in the robot, right? Because now we can tell, because he's got his computer in front of him, we can see that computer. Whereas When he's normally in a meeting, you know, he's checking email and stuff while he's talking to us, and we can't tell the difference between the two. For us as locals, for me it's weird. So the techs are 5'2", and that's my height, which means that I get to be eye level with Dallas whenever I talk to him. But when he comes in person, he's actually over 6 feet tall, and I don't like that. I much prefer that he be my height. He prefers that he's this tall, and it's different. It still is different. It's not the same as face-to-face. Nothing probably ever will be, but it can be different in really interesting ways. Right, so with that, I'll wrap up my talk. I'm happy to answer questions or clarify anything that I can, and I'd invite all of you here who know anything about humans or computers or human-computer interaction to, you know, consider playing with robots, because they're really fun and they're finally here, and we can actually play with them in spaces that are a little bit safer and cheaper than they were before. Thanks.
Yeah. Questions?
Do you have any interaction with the folks at NASA who do robotics? And
a little bit.
HRI?
Terry Fong is my favorite guy there, and they do really interesting work with that little ball that floats around and helps you remember what to do next. That's my favorite one of theirs, but they've also got the Robonaut, I think, which they're launching into space pretty soon.
Are they interested in PR2 or its descendants for their work? Or
I'm not sure.
Open source robotics?
We're trying to get them interested in open source robotics. We're actually, right now we're trying to get everyone interested in open sourcing all their code. So far I don't think we've pushed NASA too hard on it, but we have been talking with them a lot. There's a new Silicon Valley Robotics Forum where all of the companies from the Bay Area are getting together to talk a lot more, and that's where we've been pushing, sort of like, you know, you have really awesome stuff, you should share it. And NASA is one of those players.
I was wondering where Willow Garage came up with that 5'2" idea, and like, did it impact maybe Dallas's perspective on, because he's suddenly shorter now?
I think it makes him more empathetic with me, which I like. The reason that it's 5'2" is because it's halfway between standing and sitting. Ideally, you could actually telescope it up and down so that you have the sitting height robot and the standing height robot. We recently took him to a party that was a cocktail party, so everyone was standing around in dresses and fancy clothes and stuff, so he had to like get his own beer to bring to the party on his end. But what he really didn't like was that people wouldn't pay attention to him because they didn't see him because he was my height. And I told him, like, you know, that's just how life is when you're 5'2". I'm not making you taller. Yeah, get over it. That's my answer. So the height is really interesting also because you get dominance issues, right, with tall and shorter people. So you can imagine putting this in a country where there's lots of short people and having a really tall robot. Like, I bet you get some, you know, social power points just for being bigger. Yeah, Michelle.
A couple of questions about the text. So right now, the robot can only move, and there's no other things that you can control. I'm sure you've thought about having the head turn and adding arms and all that.
We put a USB Nerf gun on it.
But the other point, and this is a reflection from playing with it a little bit, it seems like at some point it becomes tiring to ride around all these corridors, and so you want to have higher level tasks, you know, take me to the conference room or to...
Right, go to meeting room A.
And then, do you have a sense of how this was changed, the sense of embodiment from both actually sides?
I think that's going to change things in a very fundamental way. When the people have, not only is it hard for people to know who's inhabiting the robot, but when it also becomes hard to know, like, is that the robot driving or is that a person, it's going to change it too. The only reason we haven't done that yet is because we don't feel confident enough in the sensors. We didn't put like the full laser scanner sweep so you could hit stuff. I think that's going to really change the way people interact with it. And while like I agree that would be great to have, there's also this trade-off, right, of, you know, a lot of the interactions happen just because you're walking down the hallway and someone sees you and then they want to talk to you. And if you're not actually there, they're going to be less inclined, right, to try to like jump in and say hi, or ask you, did you check my email that I sent you 5 minutes ago?
Well, I guess that there's a middle ground where, you know, the dead man's interface on the train, where, you know, if you don't touch anything, the train's going to stop because you may be dead. So you could sort of have the robot take you to the conference room, but you'd have to just press the space bar so you're engaged in the task, but you don't have to do the precise driving. So
yeah, you'd probably have to do that, the dead man switch sort of thing, because you need responsibility for the robot's actions. So for legal reasons, you probably also need that too. Yeah.
I'm really fascinated by the links between what you're finding and what we found years ago with media spaces, which is the alternative where you have screens everywhere, right? And you can move around through that. And sort of thinking about what Michelle was saying, another thing that can happen is the notion of teleporting, if you will. So there are multiple robots. You had, what, 29 or something like that. If they're in different places, I don't have to actually drive through the hall, which has all the good social things that you were talking about. And sometimes I'm late for the meeting and I want to just be there. So you could imagine that. In a sense, we used to do that in our media space.
By jumping the connection.
Right. But then what happens is you get this completely different model of space. So there's the physical space, and if I want to, for example, I used to have a connection with Bill Gaver, of all things, on a long-term connection, and Victoria Bellotti and Paul Durish had another connection. Paul was in my group, and so if I wanted to talk to Paul, I'd walk into Victoria's office, and similarly, if we had these different links, and so the whole notion of real space and real time, when you go into a mixed environment like this, it's really messed up. And we actually were able to deal with that pretty easily because we understood how that all worked by living there.
Other end user.
But visitors got very confused. And I can imagine, I mean, I don't know if you've looked at that or, I guess, we explored that at all.
The closest we've gotten to that is that Dallas will tend to use about 3 robots in a given day. And so he'll often beat me to the meeting before I get there because he just logged out of one and logged into the other. And I think it's kind of funny. But whenever there's visitors who see that, they get a little weirded out by it. Because he just teleported, and the robot actually doesn't go as fast as a person walking, and so it's weird that he beat us there. So far, I think they could make sense of it, but it's going to take them a lot longer, to sort of get it. Like
unless you have metaphors like teleporting, that help people say, "Oh, that's what's happening," and then you jump.
I think teleporting probably works better for screens that are stationary. It's weird when your portal is also moving around, so they may get more confused in this situation. But we have yet to see.
Maybe you need a G-lamp
so they disappear. That'd be fun.
But it's interesting because there's some interesting similarities because people are people in space dealing with technology and communication, and some interesting differences, and it would be interesting to kind of explore that.
There's also, like you mentioned the other day, the Hydra system, where you actually have a place at the table. And I've been really curious to see, how these tabletop robots differ from the big ones, because it certainly matters that you have a location, that you occupy a space and you have a physical presence. But I'm also curious to see, how do those form factors actually change the interaction, When you're a little screen versus a big screen, we've actually tried a 30-inch monitor, and that was not okay, Like having a person's head twice as big as it should be is really creepy, and everyone stands with their backs against the wall because they don't want to get near to it.
But that's a good case of there have been systematic studies that explore the relationship of size and perception, and if it's little, you have less dominance or too much dominance, and so on. So there are some things.
But also, where can you move, If you're a tabletop robot, you're stuck here. Whereas, if I wanted to talk to any of you after this talk, you can't chase me out the door, and I can't chase you out the door because I'm tethered now to this space. Yeah, there's really interesting stuff that's not teased out yet, I think, here.
I'm afraid our official time is up. But
okay, I'm happy to hang out longer.
Hang out and ask Leila questions afterwards.
Cool, thanks for your time.
For more, please visit us at stanford.edu.